So now that we have defined formally what the coloring of a graph is, the question is now, is this the most, once that we know how to color a graph, is there a better way of coloring the graph itself? So let me start with this discussion with an example. So take this following graph, just like that one. We may say, well, to color this graph, I can color it with four colors. So I can say that this is red, this is green, this is white, and this is blue. But in order to color this graph, I don't have to use all the colors. I can just, instead of doing this, I can do this. I can keep the graph here and just alternate between two colors that I choose. Let's say red and blue. So red, blue, red, blue. So now that I've seen this, I see that this graph can be colored with two colors. The question is, can I color it with less than two colors? But for that, the answer is no. And why is that? Well, simply because once I have this graph, I notice that as long as I have one edge, well, I should have at least two colors. So this is guiding us to the following definition: the chromatic number. So I'm going to start with a graph G. Simple. The chromatic number of G is the least number of colors needed to color G. To put it formally, it is the minimum among what things? Well, among the cardinality of the colors, where you have a coloring function from V to C, where C is a coloring of the G. So is the minimum among that set. So in this case, the chromatic number of this particular graph is 2. Let's see some examples. Note that this can be colored with this many. So blue, green, blue. So for this graph here, the chromatic number that I'm going to designate by the Greek letter chi of G is 2. Here's another example.